Hi, this is Mrs. La Barbara. This is Kinematics review number 1. So this is just review. So again, it's very brief. If you need more information, you can go back to my old videos for this part. Let's talk about kinematics. Kinematics basically is to describe the motion of objects. We used words to describe motion such as scalar, vector, distance, displacement, speed, velocity, and acceleration. First, the scalar is the quantity that has no direction. A vector is a quantity has direction. Distance is how far you have, the length of the path. So from A to B, you may have different distance because your path can be different. Now, displacement only depends on two things: your starting point and your ending point. Displacement is always a straight line. Displacement means changing in position. Speed is how fast you're driving. Like on the highway, you have a speed limit, so it doesn't matter which way you're going, north or south, you have the same speed. On the other hand, velocity is a vector quantity. It has directions. You're going at 30 miles per hour going to the north or northeast. Acceleration is another vector quantity. It has directions and also has magnitude. Magnitude is just means how big a quantity is. So acceleration really means how velocity is changing. We use the equations to describe motion, and the first one here have v equals d over t. This v with a bar means average velocity. We also learned instantaneous velocity is velocity at instant, but this is average. Average is total distance divided by total time. For average speed, or total displacement divided by total time, that gives you average velocity. For an object with constant acceleration, average velocity is the average of initial plus final divided by 2. So here is the definition of acceleration. That basically tells you acceleration is change of velocity over time, is to indicate how velocity is changing. And we also learn for constant acceleration, we can find displacement if we know initial velocity, time, and acceleration. Another equation gives us the relationship between quantities is called a timeless equation. We use this equation when we do not have time. Free fall is a special situation for constant acceleration. So for free fall, acceleration is negative 9.81 meters per second. This negative does not mean acceleration is less than 0. It means acceleration is downward. So there are special cases for dropped object, initial velocity equals to 0. For an object that's going up and coming down, we know the motion is symmetrical. That means the time go up is the same as time comes down. At the very top, velocity equals to 0. Also, acceleration is constant. Your initial velocity and a final velocity have the same magnitude but opposite direction. Let's apply this to some problems. The first question says one car travels 60 meters due east in 5 seconds. The second car travels 96 meters due west in 8 seconds. During their periods of travel, the car definitely have the same quantity? Average velocity, total displacement, change in momentum, or average speed. So we know velocity is a vector quantity that has directions. Take a look at the first one, you're going east. And the second one, you're going west. We know direction is different, so it cannot be average velocity. The second one is total displacement. Displacement is another vector quantity. It depends on direction. We know they cannot be the same because one is east, one is west, and they don't have the same magnitude either. The choice C is change in momentum. What's change in momentum? If you look at a reference table, we use P for momentum. Delta means change. This momentum is defined as mass times velocity. We know mass doesn't change, so it's mass times change velocity. So what is the mass? We really don't know. We don't know how one car's mass compared to the other car's mass. We don't know what that is. We really also don't know how is velocity changing. We don't know if it's driving constant with constant speed or it's changing. We only know it's the average. This is the average speed of one car and average speed of the other car. So we don't really know, not having enough information for part C. Last one is average speed. Average speed is total distance divided by total time. Take a look at the first one, 60 total distance, time is 5 seconds, so we have 12 meters per second. For the question of the other car is 96 meters in 8 seconds, so 96 divided by 80 is also 12. So we know this is correct. Another example, a basketball player jumps straight up to grab a rebound. If she was in the air for 1 second, that seems like a long time. How high did she jump? So if you try to draw a picture, the basketball player would be going up and down. We know going up time has to be the same as coming down. So up time is 0.5 seconds and down time has to be 0.5 seconds. Because total is 1, that means 0.5 for up and 0.5 for down. We also know at the very top v equals 0. The other thing we know, because she's in air, so acceleration is negative 9.81 meters per second squared. We also know that. So whenever you know 3 things, you can figure out the rest. This one is asking you how high did she jump. Height is a displacement. So dy equals VIYT plus 1/2 AYT squared. Okay, VIY, for going up, we really don't know what that is, but we know coming down. Coming down, VIY equals 0. We also know AY, we also know T. So we use the come down that direction to figure out how high she jumped. So plug everything in. dy equals, this part becomes 0, it's just 1/2 negative 9.81 times 0.5 squared. So 0.5, that's a quarter, so that's total height would be about, let's see, 1.2 meters, about 1.2 meters, something like that. So it's negative 1.2 meters, about. Again, what the negative means is the player is falling down from the highest point downward. So negative does not mean it's less than 0. Take a look at the next one. How far will break start from rest to fall freely in 2.5 seconds? So a break is falling. We know VI equals to 0. We know T equals to 2.5 seconds. And because it's free fall, we know acceleration is negative 9.81 meters per second squared. So again, we try to find dy equals to. So we use the same equation we did before. Dy equals to VIY VIT plus 1/2 AT squared. 0 times anything equals to 0. That's cancelled. 1/2 times 9.81 times 2.5 squared. So that will give you about negative 31 meters. And this negative just means downward. Does not mean the number is less than 0. So the answer should be 31 meters. Okay, take a look at this one. A car travels due north 15 seconds and night travels 90 meters. So a car going 90 meters, in this case, going to the north, right? Then comes back, travels 40 meters in 5 seconds. So this is 5 seconds and this is 15 seconds. What is magnitude and direction of average velocity? Average velocity, V equals d over t. In this equation, for velocity, d is displacement. So total displacement is you start from here, you end over here. So total displacement is 50 meters going to the north. That's the total displacement. 50 meters going to the north. What's the total time? 15 plus 5, that's 20 seconds. So you have 2.5 meters per second going to the north. That's a magnitude and the direction. That's magnitude. First one is magnitude, second one is direction. Next one, what is the average speed? Average speed, we have the same equation, d over t. But in this equation, for speed, this d is total distance. Total distance is 90 plus 40, which is 130 meters. Total time is, again, 20 seconds. And that gives you 6.5 meters per second. This one doesn't have direction. Average speed is just a scalar quantity. It's 6.5 meters per second. And that's that. Last question. A baseball pitcher throws a fastball 50 meters per second, 20 meters from the pitcher. So the distance is 20 meters and the speed is 50 meters per second. And what is the time? Because it's a fastball and there is no acceleration after the ball leaves the pitcher's hand. So acceleration in this case is 0. We're trying to find t. We know v equals d over t. Remember, this two can be switched. So t equals d over v, 20 divided by 50, that gives you 0.4 seconds. Okay, this is 20 meters, 50 meters per second, give you 0.4 seconds. And that's the answer. Okay, that's it. Thanks for watching.